Merge two sorted lists. There's our next one. So let's close that. What do we got? You're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. The list should be made by splicing together the nodes. Okay, this is interesting. So now what we have is this. So in order to write our tests, we're going to have to re-implement this. Why don't we create like a little utilities? Because I think this isn't going to be the only case where we're going to need to implement our own structs. So let's make dir source utils, let's say, and inside our lib, we'll say pub use utils, pub mod utils, pub use utils : star, and this should fail. And what we'll do is create this mod file like this, and we'll say, and this is going to be a linked list, so let's just call it pub mod list, pub use list : star, and then this should say utils list doesn't exist, and so now we'll create it, and we'll just copy paste this thing in here, and then we'll have to add some routines, I guess, or tests. Delete all these comments. I'm sure there's a way to do it in NeoVim. This should be pub new. Oops. There. Okay, so now all the tests still pass. And we should write a little test for this. But what I think I want to do, right, because we need to be able to generate these lists from these vectors. So that means that I need to go and create a function that just says, it's called from vec, I guess. And let's call it, and these are all I32s. This would be nice to make it a generic type, but let's use I32 for now. And then this returns itself. Actually, I'm going to change this as well. And how do we create a list from a vec? We need to create the head node and then replace, that's going to be difficult because we're going to need to keep a pointer to the head of the list while we're walking through the list, which means we need something, or maybe this is being too clever. We could create the list in reverse order. So we create the last one first and then move our reference to the one before it and then assign the next pointer to the first one we made. That might be the easiest way to do it rather than trying to have multiple things point to the first node. Because we're going to need, what I'm thinking is, we'll need the head pointing here. And then we'll also need a pointer which moves its way along as we're adding nodes to the end of the thing. And this pointer is going to be a read-only reference. Sorry, this head is going to be read-only reference to the first thing, and pointer has to be a writable reference to each one. And we can't have that, a head and pointer. Rust won't allow that. But if we build the last one first, let's try that. And we'll just say result is, should we just start with the last one? No, we're going to say none because we have option. So now we can say for entry in vec.iter reverse, our next entry is going to be self new, of entry dot, yeah, entry, right? What is entry? Entry, oh, is a reference to I32. So star entry. And then we'll say next, maybe I shouldn't call it next, node. Node.next is equal to result. And then we're going to update result to be sum, because this is the option thing, sum box new of node. And that should work its way up through the list. And then what we return is going to be, because what we need for this problem is this option box node business. Yeah. Negvorsa says, yes, backward makes sense. Yeah. Well, let's see if this works. Let's write a test for it. Let's just do a create list just to make sure it's working. And we can do say is let list is equal to ListNode from vec. And we'll pass in a vec of 1, 2, 3, 4, 5. And now I just want to walk the resulting list. Okay, let's do this. Let's say mute list, and then we can say while let some entry in list is equal to list. We can compare it to a known quantity. Let mot n equals 1. So we'll start n at 1. We'll say if assert equals entry is equal to n, and then increment n, and then set list to be entry.next. That way we walk the list. Oh, that's a box list node. So do we have to deref it? Oh, it's a box of a list node. So we say entry val is equal to n. And then here we want to assert that the list has, we've got to none. But that should be true in order to get out of this loop, right? Oh, so that worked. So we were able to build a list that went 1, 2, 3, 4, 5, and we verified that it was 1, 2, 3, 4, 5. We can debug out each one of these and then just do an assert false just to see them. Println entry is equal to entry. Oh, using debug there. Oh, ListNode can't be, oh, because I forgot to do that. There we go. Oh, that's interesting. So it actually contains, each entry contains everything. That's frustratingly bad, but I guess that makes sense. So we can see 1, 2, 3, 4, 5 here, and as we walk the list. That means we're not just pulling one node off of the list. We got the whole list. Okay, that's fine. And we don't need that or that. Okay, so now we have list. Let's commit those changes. Git commit, add source, show staged, git diff staged. Yep, so this is our mod utils. And this is our first utility. And then there's that. Okay, git commit -m a list utility. And now we can solve this thing. Well, we can start to solve this.